Alright, welcome to section 6.3, complex fractions. So first off, what is a complex fraction? Well, basically, it is a fraction that contains a fraction in the top, so go ahead and just write r over x, and a fraction in the bottom, maybe y over m. Very generically, it's just a fraction with a fraction on the top and a fraction on the bottom, which makes it considered complex. So let's take a look at example 1. Do as indicated. Well, what is being indicated? We have some division going on between the fractions. So there are a few different ways to work with this, and I'll show you one way. So the first one is if in the top we only have one fraction and in the bottom we only have one fraction, what I'll go ahead is I'll rewrite it. I'll do x plus 1, and then I'm going to translate this division symbol right here into the regular division symbol we know, and then rewrite this fraction right here, x minus 1 over 2x. And I usually do this method when I just have one fraction over the other fraction. Alright, so now we have it. It looks kind of simple. Let's go ahead and change this to multiplication. So keep, change, and then flip. So 2x over x minus 1. Alrighty, and then let's see. These two are binomials. Can we simplify anything? Well, we can cancel those x's. Other than that, though, we're basically done. So we can go ahead and multiply across, and that's it. We can't cancel anything else. Careful, don't multiply the 2 in. Why not? Because you're supposed to leave it factored. Alrighty, and that is it for this problem. Let's take a look at the next one. So this one's a little different. Instead of one fraction on the top and one on the bottom, we actually have two fractions on the top and two on the bottom. So my method for solving is going to be a little different. Let me go ahead and rewrite this to make it a little bigger. So what will my method be? Well, it's going to involve the common denominator. So I'm going to go ahead and focus on the mini fractions, I like to call them. These guys right here. And I want to create the lowest common denominator of my mini fractions. So once again, I always just pick the first one, plop it down. That's satisfied. Let's take a look at the next denominator. Do we have a y? No. So let's go ahead and add a y, and now this one's satisfied. Let's take a look at the third denominator. Do we have an x squared? Well, we have an x, but we don't have an x squared, so we need to add one more x, and we get the x squared, and now this one's satisfied as well. And then let's take a look at the fourth denominator. Do we have a y squared? Well, we have a y, but that's not enough. We need a y squared. So I'll go ahead and add in the y squared. And now all of our denominators are covered, so now let's use the common denominator. Now what do we do with it? Well, the same thing we did before. We'll multiply the top of the denominator, the top of the fraction, and the bottom of the fraction by the exact same thing. Alright, and once we do that, we'll go ahead and distribute this into each of the mini fractions. There's a lot going on, so take your time, pause the video if you need to. So we have 1 over x times x squared y squared plus 1 over y times the x squared y squared all over, and this is that big fraction from right there. That's this one right here. And in the bottom, once again, we also distribute it, so we have 1 over x squared y squared minus 1 over y squared x squared y squared. And what was the goal of this? The goal to cancel the mini fractions. Let's see if that worked. Well, the x cancels with that x, so we just have one x left. The y cancels with one of those y's, so we have y. X squareds totally cancel, and the y squareds totally cancel. So what do I have? I have in the top just the y squared, so y squared plus just the x squared all over the bottom y squared and the bottom x squared. Alright, so that looks like all that we have. Oops, I forgot the x and I forgot the y. Alright, so next thing we have to do is factor. And once we factor, we can see if anything can cancel. So in the top, they both have an x and a y. So we're left with a y plus x. And in the bottom, can we factor that? We can. It's the difference of squares. Let's go ahead and factor that. That difference of squares likes to pop up. Watch out for it. Okay, so we factored it. Can we cancel anything? We can. The y plus x's. And then we're just left with xy over y minus x. And we're done. So once again, the methods were different for each of these, and the method that I chose depended on the fraction. So the first one, once again, we only had one fraction over the other. The second one had two fractions in the top and two in the bottom, which is why I chose the common denominator method. Alright, let's take a look at the next example. Do as indicated. Okay, so this first one, A, which method should I choose? Well, looking at the top, I see I have two items in the top and two in the bottom. They're not both fractions, but I have two in the top and two in the bottom. So because of that, I'm going to go ahead and choose the common denominator method. So let's go ahead and set up for that. And to make it easier, I'm going to go ahead and create a fraction with the 2p and the 3p. And once again, you can do that with any number. Just put it over 1 and you've created a fraction. So now I want to find a common denominator to get rid of the mini fractions. So once again, I'm going to focus on the mini fractions and create a common denominator. Well, in the first one we only have a 1, so that's kind of already in my common denominator. The next one I have a p minus 1. So let me go ahead and include that. That works. This denominator has a 1, kind of already have that, doesn't matter. And the last one, I need a p. Now be careful. You might be tempted to say, hey, I have a p. But that p, remember, is part of this binomial, so we can't include that. So I have to go ahead and include the other p. Once again, be careful about that. I do see that mistake happen a lot, so just take a moment, pause the video, and focus on that for a second. Alright, so what do we do with our common denominator? The building up property. Go ahead and multiply the top by p times p minus 1, and the denominator by p times p minus 1. Once I do that, I can go ahead and distribute to each term, and remember the hope is that I cancel the mini fractions. So I have 2p in the top, and we multiply that by p times p minus 1, plus the 5 over p minus 1, with the p times the p minus 1, divided by 3p times the p minus 1, minus the 2 over p times p and p minus 1. Alrighty, nothing cancels in the first fraction, because remember that was just over 1, as well as that one. But in the other one, the p minus 1's cancel there, nothing cancels here, but those two cancel for that fraction. And do we cancel the mini fractions? Well, let's see. So we get 2p squared times p minus 1 plus 5p divided by 3p squared times p minus 1 minus 2 times p minus 1. And yes, the mini fractions are gone. Awesome. Next step to do is multiply things out and then simplify. So let's see. In the numerator, let's go ahead and multiply out, and we get 2p cubed minus 2p squared plus 5p. And in the bottom, let's see, what do we get? Well, they both share the factor of p minus 1, so I'm going to go ahead and actually factor that out. So I have p minus 1, and then 3p squared minus 2. Alright, so looking at the numerator, can we factor that? Well, we can take out a p. They all share a p, so we'll go ahead and get 2p squared minus 2p plus 5 all over p minus 1 times 3p squared minus 2. And let's see, can we factor the trinomial here? Well, 5 times 1 is from this factor, and for this factor, it's 2 times 1. Can we add those to get a negative 2? 2 times 1 is 2, 5 times 1 is 5. I can't get a negative 2 with that. The other way, 1 times 1 is 1, 2 times 5 is 10, and I can't get a 2 from that either. So we can't actually factor that. Alrighty, and that is going to be it. We factored it as much as we can. So once you try and factor it, if you can't simplify anything, then you are done. Alrighty, and that is it. Not the prettiest answer, but it'll do. Alright, let's take a look at the last one. Now, there's something weird about this one. Can you figure out what it is? I'll give you a hint. We have negative exponents. Okay, so negative exponents. What do we do with them? We have to get rid of them, right? We have to use the reciprocal rule. So m to the negative 1 power is going to be 1 over m. Plus, well, p to the negative 2 power is going to be 1 over p squared. And then 2, oh, careful here. The 2 is not part of the negative 2, so the 2 is going to stay on the top. And the m will go to the denominator. Minus 1 over, and then p to the negative 1 is p. Aha, what do we have? We have a complex fraction. So once again, if you have the negative exponents, you gotta do the reciprocal. Well, we have a complex fraction. What do we do with those? Well, we want to get rid of the many fractions, and to do that, we need to create a common denominator. So let's take a look at all the many fractions and create a common denominator. Once again, I always just pick the first one, plop that in, m, we're done. Now, do we have a p squared? We don't. Let's go ahead, add a p squared, and now we do. Let's take a look at the next one. Do we have an m squared? We don't. So we gotta go ahead, add that square, and we're done. Lastly, do we have a p? Yeah, we already have a p. We have 2 p's. We're done. We don't need more than 2. So, we've created our common denominator. Let's go ahead and do the building up property. M squared p squared to the top, and m squared p squared to the bottom. And then we'll go ahead and distribute those to each of the factors. So that's going to equal 1 over m times m squared p squared plus 1 over p squared times m squared p squared. All over, once again, this fraction is the one right here. 2 over m squared times m squared p squared minus 1 over p m squared p squared. All right, so we went ahead and distributed that out. Let's go ahead and simplify and see if we have any fractions left. M squareds cancel, p and p. All right, what do we have left? mp squared plus m squared all over 2p squared minus m squared. Okay, let's see. Can we simplify any of these? Well, in the top, we have an m we can factor out. So you have m and then p squared plus m. And in the bottom, we have 2. Oh, we can't factor anything out. You might be tempted to do the difference of squares. However, we have that 2 by the p squared, which is not a perfect square. So we can't actually factor that. So we're actually done. We can't factor any of these any further. So we're done. All right, and that is it for this section. Once again, please stop by my office hours or email me if you have any questions. Once again, my office hours are there for you to ask me questions about any of the lecture notes or any of the homeworks.